A large tank holds 100 gallons of fluid in which 10 pounds of salt is dissolved. Fresh brine of concentration half a pound of salt per gallon is pumped into the tank at a rate of 6 gallons per minute, and the well-mixed solution is then pumped out at a slower rate of 4 gallons per minute. Let's go through some of the details here. Now this 100 gallons is the initial volume of fluid in the tank. 10 pounds here is the initial amount of salt in the tank. So we get an initial condition A of 0 is equals to 10. Now let's write down some of these particulars here. The rate of the inflowing liquid is 6 gallons per minute here. The concentration of the inflowing liquid is 0.5, and so we get R in as 6 multiplied by 0.5 as 3. Now for the outflowing liquid, we have a rate of 4 gallons per minute, and this means that brine is flowing into the tank at a rate of 6, which is faster than the rate at which the brine is flowing out. This means that the volume in the tank will keep increasing. Now to figure out the concentration, so we have amount over volume, so I'm going to call this A for amount, and the volume now will be the initial volume plus the increase in volume. Now how do we figure out the increase in volume? You notice the difference here is 2, 6 minus 4. So every minute the volume is increasing by 2 gallons. This means after t minutes the volume will increase by 2t. So our volume is 100 plus 2t. So the R out is rate times concentration is 4A over 100 plus 2t, and this is 2A over 50 plus t. Next, the differential equation for the mixture problem is dA dt equals to R in minus R out. So we write this down and we rearrange this, and we get dA dt plus 2A over 50 plus t equals to 3. Now this equation is linear. So the way to solve linear equations is by figuring out the integrating factor, which is e to the power of the integral of 2 over 50 plus t. Now this is e to the power of 2 log 50 plus t, and this simplifies to 50 plus t squared. Now I'm going to multiply equation 1 by the integrating factor, and so we have 50 plus t squared multiplied by dA dt plus 2A over 50 plus t is equals to 3 multiplied by 50 plus t squared. So the left hand side simplifies to d dt of A multiplied by the IF. Now we write d of A multiplied by 50 plus t squared equals to 3 times 50 plus t squared. Bring the dt over and we integrate both sides. So now we get A multiplied by 50 plus t squared on the left, and on the right we get 3 divided by 3, 50 plus t cubed plus c. So if we divide through by 50 plus t squared, we get here 50 plus t now to the power of 1 plus c over 50 plus t squared. Now we plug in our initial condition and we get 10 equals to 50 plus c over 50 squared, which means c is minus 40 multiplied by 50 squared, which is minus 100,000. And then we can write our equation for the amount of salt in the tank as 50 plus t minus 100,000 over 50 plus t squared. And for the B part of the question requires us to find the time when the brine reaches capacity if the capacity of the tank is 250 gallons. So the volume, we know from the earlier part that the volume is 100 plus 2t. So if the capacity is 250, we just create these two and find t, which turns out to be 75 minutes.